Okay, class, in Unit 2, the vocabulary has to do with proportional relationships. In order to understand proportional relationships, you need to understand ratios. Ratios are a way to compare numbers. That's what we were doing when we were dealing with probability in Unit 1. Okay, and we have several examples, but most ratios are presented in the simplest form. So I gave an example of 3 to 5 with the word 2 in between. 3/5 as a fraction, 3 out of 5, again, word form, and then with the colon there, 3/5, okay, or 3 to 5. Unit rate is another important word. That's one of the main focuses and one essential standard in this unit. When a ratio has a denominator of 1, an example would be if you were given a scenario where you had 150 pencils, you want to divide them equally among 30 students. You would simply find the unit rate by dividing the total number of pencils by the number of students that you have, and then you would end up with an equivalent ratio there with a unit rate of 1 student, 5 pencils to 1 student. Once you come up with unit rate, we often want to know if things are proportional or non-proportional. I've given 2 data tables here as examples, but if 2 quantities have a constant ratio, okay, they are considered proportional. An example of this, we had a cost of pizza, okay? For example, 1 pizza, which is on the bottom of the graph there, is equal to $8. Okay, so if you bought 2 pizzas, if it was proportional, it would cost $16. 3 pizzas would be $24, and 4 pizzas would be $32, and so on. This is a proportional example. If it was non-proportional, it may provide something like this. If the ratio is not constant in the relationship between the 2 quantities, you are not going to see that pattern showing up. Or an example here is if I buy 1 pizza and it costs $10, but I buy a second pizza and it now costs $17. If it had been proportional, I would have seen a consistent pattern of, say, $10 per pizza, $20, $30. But in this case, they're actually showing how the more pizzas you buy, the less expensive each pizza becomes. Therefore, this is a non-proportional example because you cannot just plug in one constant of proportionality and come up with this solution. We'll discuss more on that term later. Quantities are simply amounts. Just get used to hearing that. Discount. These are a part of the supporting standards. Discounts are the amount by which the regular price of an item is reduced. You see a lot of discounts at stores trying to get you or entice you into purchasing their products. Equivalent ratios, just 2 ratios that have the same value. For example, we did a lot of equivalent fractions or simplest form in the last unit. So 1/2 is equal to 8/16 would be an example. A tip is almost the opposite of a discount because it's a small amount of money added to the original price for good service. Okay, so discounts are amounts of money taken away from the original price, whereas a tip is in addition to. Okay, and then sales tax. Sales tax is in addition to the money. You add that to the price of the item. The difference between a tip and sales tax, while they are both in addition to the original price of the item, a tip is your preference. Okay? Sales tax is not optional. If you live within the state of Washington, you are required to pay sales tax. Okay? So these are the vocabulary terms that we are going to start with. There are a few others that you may hear, and if necessary, we will ask you to write these down. Please go and record these in your math notebook under your new section of Unit 2. Unit 1 is complete. We need the vocabulary for Unit 2 written down as well, and we will require you to show us for a grade.